Okay, fine. I guess we can start then. Okay, so today we are going to be discussing binary search and also interactive problems. So generally, interactive problems, they happen together with binary search. Like most interactive problems are based on binary search. That's not always the case, but in more than 75% of the problems, you'd be using a binary search to solve the interactive problem. So we'll be discussing like interactive problems, and I'm sure everyone already knows what binary search is, obviously, since you are all in level 3. And like we are going to be discussing binary search like pretty quickly, but it won't be deeply. Okay, so let us start, I guess. Fine. So the first thing that we are going to be discussing is in fact binary search. Like I'll just quickly go through this. Everyone knows this again. I know that everyone knows this, but basically it is just a searching algorithm for a sorted collection of data. So it can be sorted based on anything. Like for example, it can be ascending, descending. You can do any custom sort, right? You can do any custom sort, and as long as it is, as long as it is strictly monotonic rather than just jumping around all the place, well, you can perform binary search on it. Like as long as your search function is monotonic and your binary search sorted array is also monotonic, you can do binary search on it. Okay, then. And again, we know that it divides the range by half every time. So that makes the time complexity of log n. So since we keep dividing by 2, it will take log n times to get to 1. So that time complexity is O of log n. And for 10 power 6 elements, it takes approximately 20 iterations. Okay, cool. I don't think I need to dwell on this much. But this next part is pretty important. Like for many things in the future, this will be important. So I'll just dwell on this a little bit. Like people from level 2 should know this. People from level 2 who have been in level 2 before should know this, but it's fine. Like many people here are new. So I will discuss this once. Okay. So basically, when does actually binary search work? Like I did discuss that it has to be monotonic, but it also like you can also say that in a different way, right? So let's say that you have a set of elements. So binary search, it works on a set of elements basically, where the predicate function. So I'll come to this predicate function in a second. So if you apply this predicate function, this magic predicate function, it should be of the form true, 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 and then false, 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 right? So basically, what a predicate function does is, I'll just write pred. So pred, let's say, is predicate. So what this predicate function does is it says whether you need to go to the right or whether you need to go to the left. So it just says in the binary search, if you have a list of elements, you have a list of elements. When you take half of this, it says whether you want to go to the left side or the right side, right? So it says left or right. So this is the only thing that predicate function does. Now, since we only have 2 directions to go in, the predicate function will always be bool. So predicate function is bool, which basically means that you will always go either left or right. So basically it's a bool, right? If it's 0, let's say it goes to the left, and let's say if it's 1, it goes to the right or something like that, right? So basically here, what this binary search will do is whenever the predicate is true, right? So whenever the predicate is true, it goes to the right side. So left is 0, right is 1, let's say. So whenever the predicate is 0, let us say that we have a range. This is L and this is R, right? We have an array, we have a big array, but this is a small path, right? Because binary search takes, only the, like, we have a lot of values over here, a lot of values over here. Now binary search splits this array. So let us say this is L and this is R. So we have some values here, let's say 1, 2, 3 or something. Then you have 4, 5, 6 over here. And we have 7, 8, 9 over here. Like this won't happen in an actual binary search because you'd be at 5 in the beginning itself. But it doesn't matter. Let's just take this as some sample array. Now, what this does is if the predicate function is true, right? So if the predicate function returns true, then you move L to mid. So we take this left side and we move it to mid. And well, if it is true, right? So if it is true, we are moving it to mid, which basically means that you are going to the right side, right? So this is the right side. So you are going from the middle to the right side. So the right side of the middle part. And if the predicate function is false, so if the predicate is false, we move R to middle. So let's say this is L. Now R will move to middle, right? So R will move over here, which would mean that you are basically going to the left side. So you are only considering this part. Everything over here has been ignored, right? So everything over there has been ignored. Now let's try to take a small example. Let us say we have 1, 2, 3. Okay, someone's annotating. I once again, just let me. The bool function is wrong. Which one? Which one is wrong, Aman? Aman, I'm not able to hear you actually. So you are unmuted. I see that you are unmuted, but I'm not able to hear you. I'm still not able to hear you, unfortunately. Okay, fine. I'll just take an example and then we'll continue. Okay. Okay, let us say that we have this as our binary search. Generally, what we'll do is take, let's say we are looking for a target. L will go to mid if predicate is false. L will go to mid if predicate is false. Okay, so the predicate function is like, you can, in the predicate function, like I can define it however I want, right? So I can say that my predicate function will go to take L to mid when the predicate is true and R to mid when predicate is false. So I can say this, and you can say that my predicate function will take false if L to mid will be false and R to mid will be true, right? So it depends upon your implementation. Like if you implemented your predicate function such that L to mid is true and R to mid is false, then that will happen. But let us take this case. Let us say that, like, what does binary search actually does, right? Let's consider what the binary search actually does. So we have trues and we have false. Now, what this does is it just basically finds the last true. It finds the last true or the first false, right? So this is how I'm defining my binary search. Now, if I take L as this and R as this, and let's say I take some value, let's say I take some random value as this, right? It's true. Now, if I clearly want to go to the boundary, then if it is true, I go to the right? So L is going to mid when the predicate is true. Over here, the predicate is true. So I'm moving L to mid. Right? So what binary search actually does in general is that it takes the boundaries. It takes the path where true is there and then the next value is false, right? So we want to find the perfect balance. Now, what we are saying is when I take this boundary over here, L as this and R as this. Now here, let us take the middle value. Let's take some middle value. Now what I'm saying is, okay, from this middle value, well, should I go to the right or should I go to the left? Well, here, since it's on the boundary, it depends on your implementation. But let's say we are at some random value over here. Then in this case, clearly we need to go to the right? So the predicate function over here says that you need to go to the right. Now, if I was here, it says that you need to go to the left. So to find the different values, you need to go to the left. Over here, you need to go to the right. Does this make sense, Aman? Is this clear? If L plus 1 equal to R. Yes. If L plus 1 equal to R, we stop. Like basically, like this is just a pseudocode, right? I'm not telling you the exact full implementation, obviously. Yeah. Okay, cool. One second. Let me just disable annotations and then we'll continue. Okay, fine. So yeah, so binary search basically is a bunch of truths at the beginning and a bunch of false at the end. And we are defining our predicate function such that L will move to mid. So like mid value is anything that you choose. You can choose whatever mid value you want. Like generally though in binary search, it's obviously L plus R by 2, right? So if L2 will move L to mid when predicate is true and R to mid when predicate is false. Okay, is this clear to everyone? Please let me know with a +1 in the chat if it's clear. And otherwise you can also ask any doubts if you have any. If you have any doubts, please feel free to ask, by the way. Okay, cool. Okay, fine. I guess we can move on. Okay, so let us actually discuss a binary search method. So I'll discuss my binary search method. This always works for me. So I always use this binary search method. So I'll discuss this. Just give me a second. I'll just take a screenshot of this and put it in my draw thing. Okay. Now, basically, in this binary search method, what you have to do is consider a range L, R, except that both are exclusive, right? So both L and R are exclusive. So the polar opposite of this would be like, if I take L equal to min. So min is basically the minimum value of the search space. So for example, let us say we have an array from 0 to n minus 1, right? Let's say we have an array from 0 to n minus 1, indices 0 to n minus 1. Then min over here will be 0 and max over here will be n minus 1. So L and R will be -1 and n respectively, right? Now, again, this basically means that if I'm taking -1 and n, this is referring to the range L to R, both exclusive. Both are exclusive. So you're not including L and you're not including R. Okay. Now, what we are going to do is say while R minus L is greater than 1. So while R minus L greater than 1, what this means is that if you take L and if you take R, right? Like if there is nothing in between, right? So if I take L comma L plus 1, then both are exclusive. We are assuming that everything is an integer here. And if both are exclusive, notice that we have nothing in between, right? We have nothing in between. So there is nothing in between. So, well, there is, you don't have to go after that. So when L and R are having a difference of 1 or lesser, you can immediately stop. So while R minus L is greater than 1, so while R minus L is strictly greater than 1, we'll take m equal to L plus R by 2. We'll take m equal to L plus R by 2. And we'll say if predicate L moves to m, right? So like we discussed here, if this is true, then L is going to m and otherwise R is going to m. Now, what this means is that basically, let's say we have L and R equal to, let's say 1 and 5 respectively. Then what this means is that is actually a range from 2 to 4, right? So this is actually a range from 2 to 4. Now, let us take L plus R by 2. That would be 6 by 2, 3, right? So say 6 by 2, 3. Now at 3, let's just assume that predicate at 3 is equal to false, which basically means that we'll move R to 3, right? So we'll be moving R to 3. So R will be equal to 3 now. So this will become 3. Now, if you take the thing again, if you take the predicate again, then that would be predicate of 2, right? So that would be predicate of 2. Now let us say that predicate of 2 is true. Let's say predicate of 2 is true. Then in that case, well, we'll be moving L to that. So this will become 2, 3. And at 2, 3, we will stop. We'll stop going any further than this. Now, the neat part about this is actually that after the end of this entire thing, after this entire thing ends, L will be the last true. L will be the last true. And R will be the first false, right? Okay, let me explain. Let's say that our predicate function, okay, let's say we have 1, 2, 2, 3, 3, 3, 4, 4, 5, 5, 5. Now, let's just assume that I'm looking for the last occurrence of 3, right? I'm looking for the last occurrence of 3. Okay, let's say last occurrence of 4, actually. Now, in my predicate function, like what will my predicate function be? Can someone tell me? If I want to find the last occurrence of true, what will be my predicate function? So till when do I need to keep going to the right side? When should I keep going to the right side? Less than or equal to 4 is true. Exactly, Banu. And Shivang is also correct. Shivang, Abdur, Aman, etc. Okay, there you go. Yes, that is correct. When A of middle is less than or equal to 4, we'll keep going to the right. Okay, so what this means is if I take A of mid less than or equal to 4, then actually, like, I'll tell you a basic way where how you can predict the predicate function. Basically, you can say that I'll just take anything, right? Anything such that my target is either the last true or the first false, right? So if I take A of middle less than or equal to 4, then all of this will be true. All of this over here, this will be true, right? And notice that after this, this will be false. So for the last 4, I want to find the last 4. Then in this case, what happens is that the predicate function, notice that we either have the first, like last true or the first false, right? So your answer, like your predicate function should give you the answer as the last true or the first false. So you need to choose a predicate function in that manner, right? And in this case, if you take A of middle less than or equal to any target T, so if you want to find the last target T, then in that case, you will take A of middle less than or equal to T. Because if it's less than or equal to, then you get true. Otherwise, you get false, right? Now, I'll discuss the opposite as well. How to find first 4. Okay, that's a good question, Aman. So basically, what you do here is last 3 plus 1. That works, Kaif, that works, but there's a neater solution. Like instead of taking -1 or anything like that, what I can say is simply A of middle less than target. So instead of taking A of middle less than or equal to target, what I'll say is A of middle less than target, right? Now, what will happen? What will happen is that we get true over here. Let's say target is still equal to 4. So if I take A of middle less than target, I get true, true, true. All of this will be true. And over here, this will be false, right? This will be false. Now, what happened is that we get first false as our answer. Our answer is the first false, right? So our answer is the first false. Over here, our answer was the last true. So in the previous case, when you wanted to find the last occurrence, our answer was the last true. Now it is the first false, right? That's it. By just changing the predicate function, you can immediately find which value will be our answer, right? So it will either be like, it will always be either the last true or the first false. We can set the predicate function like this and we'll take the first true. Pritham, that does work, but it's basically like inverting this thing, right? So if you just invert this thing, like in the end, it won't make a difference. Like if you say this will be false, this like beginning part will be false and the ending part will be true, then you need to change the predicate function such that L to mid will be false and R to mid will be true, right? So everything will be reversed. And in the end, everything will be the same. Yes, you are correct. Like we can change the predicate function, but then you also need to change your conditions as well. Like your condition will also be the opposite everything. Like it's your design choice, basically. It's up to you. Okay. So basically, again, in this case, we can see that we can always find the value at either the last true or the first false. Okay. Now, this binary search method that I have discussed over here, right? This binary search method that I have discussed is very, very useful because what it does is it has no confusion. It has zero confusion. Like you might know that in binary search, you might have to think about whether you need to take the seal or if you take seal. Like sometimes in binary search, you need to take L plus R plus 1 by 2, right? So sometimes when you're doing mid, you need to take L plus R plus 1 by 2. And sometimes you need to take R equal to mid plus 1 or mid minus 1. Or L equal to mid plus 1 or something like this. Like it's always weird, right? So what you can do is with this binary search function, you'll always get both the last true and the first false, which is extremely useful, right? So you always get both. And if the value doesn't exist, so let's say the last true doesn't exist. Let's say everything is false. Let's say everything was false. Then what will happen is that it just decides that the -1th index, so the search space starts here, right? We know that the min -1 is the L, which means that L plus 1, let's say L is -1. This is 0, 1, 2, and 3. And after this, it also doesn't exist. So over here, nothing exists. Over here, nothing exists. So this is a space that you want to search. So it just assumes that at the beginning, this is all true. So everything before the search space is true, right? So for example, in an array, what it says is if your array starts from 0, index 0, then everything from index -1, -2, -3, etc., these are all true, right? So these are all true. And what it says is for 4, these are all false. So all of these are false, right? So everything after the end is false and everything before the beginning is true. So this way you always get an answer. So you always get L equal to -1, basically meaning that you are out of the search range. So there's nothing there, or R equal to end of the search space plus 1, right? So R is the end of the search space, which could be n-1 in an array plus 1, right? And this way, what you get is, well, always an answer. You always get a valid answer that's, well, it might be out of the array, but you still get an answer, right? So this is what it assumes. It assumes that everything like min -1 to negative infinity is always true. And max plus 1 to positive infinity is all false. Now it takes this assumption and it does a binary search. And after the binary search, you will always get that the L is the last true and R is the first false. Now it depends on your implementation, what you want to use, right? So let us say again, in this case, for example, if you want to find the last occurrence of 4, then you need to take the first last true, right? So last occurrence of T would be the last true. and the first occurrence of T would be the first false, right? So if you want to take the target, well, either you take the last true or the first false. So that depends upon your predicate function and how you implemented your code, right? But this binary search function guarantees to give you both the last true and the first false. So this is very, very nice. Like I always use this. This always works, except in cases where you need to get a double answer. So when the answer is a floating value, then you can't use this basically. If your value is a floating return value, then you can't use this, but otherwise you can. So in every other case, you will be able to use this. Okay, is this clear to everyone? Any doubts? Also, thank you, Swaraj. Anupam, you are right. You are right. If you take an extra value answer, and you can do L equal to like, L less than or equal to R here. You can do L less than or equal to R, and you can take L plus 1, R plus 1 every single time. But whenever you take L plus 1, you will say answer equal to M. So you can say always answer equal to M. That works. You are correct. You can do that. But I just prefer this method. I don't know why. Like it's so neat and clean. So yeah. So what is predicate function? Sorry, I missed it. So Sagam, basically, what happens is a predicate function, let us say, will tell you whether you want to move L to mid or R to mid, right? So it says whether you should move the left range, like left bound to the middle, or the right bound to the middle. So if it is true, if the predicate function is true, you move the left bound to middle, and if the predicate function is false, you move right bound to middle. Now, if you have true, 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 and false, 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 this is what the predicate function is explaining, like expecting from you. So the predicate function says, okay, if I take it true, if my predicate value, return value is true, then I go to the right side, right? So it moves L to mid. So if you want to go to the right side, you move L to mid, right? So yeah, that's basically what it does. So this is the values of the predicate function for some array or something. Now, in this case, for example, let's say we want to find the last value of 4, last value of T. Then what I do is just say, okay, if I take this, notice that over here, I keep going to the right, right? So I keep going to the right until I get to 5. So my predicate function in this case is A of M less than or equal to T. So this is my predicate function. For 3, for example, I know that I need to go to the right. For 5, for example, I know I need to go to the left, right? So that's how it works. Okay, Ankur says, most of time I get W due to precision error when using binary search using predicate function, when calculating ceil or any other floating operation, any solution. So basically, Ankur, I'd suggest that you use a long double first of all. Always use a long double. Never use double or float. Long double is always better. And Aman Sharma, like we'll not be discussing problems like right now, but you can message me after the class. I'll help you out. Okay, Nikhil says for doubles we have to check if the difference between L and R are greater than some epsilon. Yes, exactly. That's exactly right, Nikhil. So you always need to check that, because otherwise it might go too precise and it will just take a long time, or it might also like make a mistake somewhere. So just make sure that if L minus R is greater than epsilon. Sukendu says, if there's a float value, can we replace R minus L greater than 1 with R minus L greater than epsilon? So that actually doesn't work, because the issue is that the middle function, the middle value, this won't work now. So what this middle value assumes is that, for example, let us say L was equal to 1 and R was equal to 4, right? So middle assumes that it will just take L plus 1, L to R. So L plus R by 2, right? So it takes L plus R by 2, which does not necessarily equal a floating number, right? So it does not necessarily equal a floating number. And so it does not always work, unfortunately. Like it sometimes fails. Like you can try it out. You can look at how it would perform on some double problem. But I have tried with using epsilon here. It generally does not work. Yes, Preetham, you can also do that. You can also say that the number of iterations has to be this much. So for example, you know for sure that it will, let's say, be less than or equal to 10 to the power of minus 6, right? So in this case, you can say that, well, I only need to go at most like 30 times. because 30 times would be approximately 10 to the power of 9, right? So you don't need to do after this time, like this amount of times. So in your binary search, you can say that for a double problem, only iterate for 30 times, because I know for sure my answer will be like the precision will be 10 to the power of minus x or something like that. Rishabh, that does not work. Again, L plus precision greater than R doesn't work in this binary search, because the mid value assumes that all of these are integers, right? So it assumes that all of these are integers because you take L comma R. So you take L comma R and you take the middle value from this. And it takes the middle value as assuming that L and R are integers, right? It takes a middle value like that. So that is the issue here. Okay, again, this L plus R less than precision less than R also doesn't work. So L plus precision less than R also doesn't work, because like if mid is also double, right? If mid is also double, it still means that L and R are exclusive. Over here, L and R are exclusive, right? Okay, you can just try some examples actually. You can just take some examples, you can try it out. But I'm pretty sure that like it doesn't work. I have tried this in the past, it hasn't worked. But maybe I'm wrong. I could be wrong. So I'll test this out with a double problem, and then I'll message you guys in the chat. Like I'll let you know if with my results later after the class. Okay, cool. Okay, fine. So far it's clear, right? So far, what we have discussed is clear. Any doubts? Please let me know with the +1 or -1 in the chat. If you have any doubts at all, you can let me know, right? If you have any doubts in general, you can let me know. So Harish, I will solve a problem. Don't worry soon. Like very soon, I'll be solving a problem. So don't worry about that. Okay. So the next thing that we are going to be discussing are interactive problems. Okay, fine. So basically, I'm sure again, many of you know what interactive problems are, but they are still actually very, very important. Like from Codeforces C onwards, you'll see many, many interactive problems. Like there are a lot of interactive problems, right? Because they are pretty unique and Codeforces likes to use them. Like in most contests, they are not there, but it's pretty common. Like it's still common, right? It's common than most algorithmic topics or anything like that. So it's very important that you know what interactive problems are. Okay. So basically, in an interactive problem, you are not just taking input and you're not just giving out the input. What you're going to be doing is take some initial values. So let me explain the process. You take some initial values, you take some like initial values, like for example, n, right? So n could be the number of elements in an array or something like that. You take something like that. And after that, what you do is ask some questions. You ask some questions, right? So the initial value is taken. Then you ask a question, and the way you ask a question is you print a value. You print a value, you do cout or anything like that. You say, for example, in many problems, they say output question mark for question. So if you are asking a question, then they say output question mark 1, right? So for example, this could represent you asking what is the first element of an array? What is A1, right? So it could represent that. Now you also have to like take input. So answer. Right, you take answer to the input, answer to the question, and that will be like the judge will give you the input. The judge will say the answer for A of 1 is like, let's say 7, right? So it could be 7 or something like that, anything like that. I'm not saying it has to be 7. Now, after that, you need to print the final answer, final result. So you need to output the final result, which could be anything like exclamatory mark. So generally, when you output an answer, like you output the final result, you'll get exclamatory mark. You'll have to print exclamatory mark. And you also have to print like, let's say 10 or anything like that. You need to print whatever your final result is. So the final result will be printed like exclamatory mark 10 or something like that, right? So this is the basic idea. So the idea is that you take some initial input, then you output the question. You output a question, and then you take the answer. So you output a question, then you take the answer, and after you do all of that, you take the final result. So you take the final result as the, well, you output this as your final answer. That is what is most important, right? So the score is based on what your final result is. Now, generally though, you also have the number of queries. So they say that you cannot use more than, let's say 50 queries, right? So let's say if you use more than 50 queries, you immediately get wrong answer. But if you use less than 50 queries, 49, even 50, you can use 50 or less. So let's say you use 10 queries, that's fine. If you use 51 queries, then you are immediately going to get a wrong answer. Okay, cool. So this is the basic idea of interactive problems. Like we'll go through some problems just to understand how this works. But one very important thing about this is that you need to remove fast IO and you need to use endl. Like you only need to do either of these, but generally I prefer to do both because it's pretty important. So you can just do both, right? So generally you can, but you need to do at least one. Like you need to at least remove fast IO or you need to at least remove endl. No, at least use endl. Okay. Now, whenever you're doing this, well, what happens is if you use fast IO, let me just show how fast IO works. 1 second. Okay, let's see what fast IO actually does. Now, note that I have used hash define endl as \n. Okay. Why we use fflash? You mean flush? Like you can use fflush, I think. Yeah, I think you mean fflush. Oh, okay. Nikhil, I will do that actually. Yeah, I will link my YouTube video about this. 1 second. So I have made a video about this actually. So like I made a full detailed video also discussing why I need to why you need to avoid using this, avoid using endl and fast IO during interactive prompts. So yeah. So I'll link it in chat. You can take a look there. But let me just briefly explain it here. Let us say that I take input, like take int and cin, but before that I say cout, enter a number, right? So I say cout, enter a number. Now let us say that I also cout, after this, enter n into 5 or something like that, right? So I just say enter this, I don't know why, but let's just say our program does this, and I take int n5 and cin n5. Now, let us say the judge will enter n into 5 if you ask it for n into 5, right? So, and if you output n into 10, it will give you n into 10. But the issue is that if I use fast IO, so I'm currently using fast IO, I'm also using hash define endl as \n. Let us actually see what happens. Now, notice that I'm not actually getting any output. I'm not getting enter a number. But let's say I still enter a number. It says now enter n into 5. I haven't printed it, right? It's not getting printed. Now let me enter 50. Now it says enter number, enter n into 5. So what's basically happening here is that you get both of these outputs like at the same time. So what happens is you take in all the input. So you take in all the input and then you do all the output immediately, instantaneously, right? So right after the program ends, you do all the output. But the reason this doesn't work, actually, let me discuss the reason it works first. The reason it works is because in most problems, they give you some fixed input, right? So they give you, let's say there are 2 test cases. There are 3 values in the array, 1, 2, and 3. There are 5 values in the array, 5, 4, 3, 2, and 1, right? So this is your input. And generally, you just have to provide outputs here. Let's say for the first one, the output is like 6, and for the second one, it's like 120. Now, this is the input and output, right? So this is the input and output, and they are mutually exclusive. Like the input and the output are not related. Like, of course, you're solving the input to output this, but the output does not affect the input. And that's pretty important, right? So the output over here does not affect the input. Now, on interactive problems, what happens is that your output does in fact affect the input, right? So your output, let's say you output n into 10, then in this case, your input is clearly going to be different. Like the judge will input something different, right? So you need to always make sure that you remove hash define endl \n and fast IO. Like obviously either one is also fine, but I just prefer doing both. Now let's see what happens. If I do this, let's see what happens, right? Now it says enter a number. So it's doing it correctly, right? So if I enter 10, it says enter n into 10. Let's say I enter 50. Oh, okay, that's supposed to be 100, but whatever, you get the idea. So you get the idea that you need to you need to never use endl, hash define endl as \n, never use this first of all, and also never use fast IO. Like again, either one is enough. Yes, either one is enough. But if I were you, I'd probably be doing both because I would not risk getting an idle limit exceeded. And in most interactive problems, like time complexity is not an issue. Like, I mean, not time complexity, but rather time optimization is not an issue, because in most interactive problems, they do realize that fast IO is not there. So they give you a lot of leeway, right? So a lot of leeway is given. And generally, the biggest problem for you would be staying within the number of queries rather than exceeding the time limit. So TLE is very uncommon with interactive problems. Okay, cool. So this is the general idea. We can't use endl in itself or endl as macro. Like basically, you can't use backslash. Let me just say this. You cannot use backslash. Cannot use backslash, but you can use endl. Okay, what about Python people like me? Nikhil, you are in luck because Python automatically flushes code. So you are in luck there. So yeah, this is only for C++ users. For Python people, you don't have to even worry about that because Python automatically takes care of stuff for you. So yeah, don't worry about that. Okay, cool. Okay, fine. Yeah, is this clear to everyone? Please let me know in the chat, with +1 or something. And if anyone has any doubts regarding this, you can also let me know that. Okay, cool. I guess this is clear to everyone then. Very nice. Can you tell the difference between endl and backslash? Okay, that's actually a good question. Again, this is explained in my video, by the way. This is explained in a lot of detail in the video. But the difference is that there is something called flushing. There's something called flushing. And what it does is whenever you output something, right? So whenever you output something, it is stored in a buffer. So there is something called a buffer. There's something called a buffer, which actually is a temporary storage. Buffer is just a temporary storage. And what it does is if you output something, it is put in the buffer. It's put in the buffer. But whenever you flush, right? So whenever you do a flush, or whenever you when you have IO sync with stdio, then what happens is that it gets added to the buffer. But when you flush, it gets removed from the buffer. If you don't have this fast IO, flushing always happens, right? If you don't have fast IO, it removes everything from the buffer. So what happens is, let's say you output, enter a number. Let's say I'll just write number. So then it immediately outputs number, right? So it immediately clears the buffer. Basically clearing the buffer or flushing the buffer means you print everything inside the buffer. Now, what happens is when you use fast IO and you use backslash, everything is stored in the buffer. So enter a number is stored in the buffer, enter a number into 5 is stored in the buffer, your final result is stored in the buffer and everything. And you just keep taking inputs, right? So you just keep taking inputs without ever going through the buffer. But when the program ends, you immediately clear the entire buffer. Now, what endl does is that whenever you output endl, so over here, we know that there is backslash, right? So clearly there has to be backslash over here. One second. This is backslash, this is backslash, and this is backslash, right? Now, what happens is when you don't use backslash, but rather use endl, the moment you output endl, it flushes the buffer. Endl flushes the buffer, which basically means that you output number first, and then you output backslash. So you output number backslash, and it is not even stored in the buffer, right? And then it is immediately, again, you immediately print number into 5, and then you also print backslash. And finally, you output result. So backslash doesn't clear the buffer, but endl does. So let me just show you. So endl is basically the same as, doing backslash plus cout.flush. Right. So what this means is, let's say I'm doing enter a number in 10 CNN, and let's actually say I'm doing endl over here. Let's say I'm doing endl over here with fast IO. I'm having fast IO. I have removed the macro. So what I'm doing is I'm actually outputting endl, which should flush, right? So over here, you will see that it outputs and enter a number. There you go. And then I get 10, right? I can enter anything like 10. But let us say I do backslash. I'll do backslash over here. Then it does not output anything. And after I entered 50, it says enter number. But if I do cout.flush, right? So if I do cout.flush, sorry, I have to do that outside like this. So if I do cout.flush like this, then let's see what happens. Well, again, we get enter number, right? So basically what endl does is it simply outputs backslash n, and it also flushes the buffer. That's it. So you can't exactly read this properly, but I'll just show you this part, right? So I'll just show you this part. What it does is it flushes and it also prints backslash n. Like, don't worry about everything that you don't understand, but basically you can see that it flushes and it also outputs backslash n, right? So this is the basic idea behind flush, basically. Okay, cool. So I hope this is clear to everyone then. Does FastIO also affect the buffer in some way? Yes, FastIO makes it so that everything is always put into the buffer. So if I don't have this and if I have backslash n, if I don't have this and I put it to the backslash n, then let's say I enter 50, right? Then it outputs. So what FastIO does is the culprit is this line. The culprit is this line over here where we have cin.tie null, right? So this removes the sync between cin and cout. So when we have the sync between cin and cout, before you take cin, you always make it so that you clear the buffer. You print everything before you take an input, right? But that does not happen. That does not happen when you have this, when you have the cin.tie null. So that's the only difference. Okay, let me do some experimentation, right? Let me quickly do some experimentation. Let's say I do cout1. And let's say I take a for loop that goes from 1 to I less than or equal to 1e9 I plus plus. Okay, now I'll just have int x equal to 0 and x plus plus. So I'm just taking some random thing. And I just want to see the difference in time, right? Let's just see if this works. Okay, that did not take long at all. Okay, fine. Let me take 1e10. Oh, what? Okay, I think C++ is optimizing this because it's not supposed to end like instantaneously. Okay, how do I fix this? What if I take only 15? Will it still finish instantaneously? I don't think so. Okay, it does. C++ is just removing this because it's an optimization. Okay. Is there a sleep method in C++? Okay, I don't know. Okay, you know what? Let's have this experiment for another day. My bad. Okay, that's fine. Anyway, so what I was trying to see was if there was a delay without cin.tie null, if there was a delay, would it print immediately or would it, would it print 1 and then would it print 2 after a delay? Or would it print 1 and 2 instantly? Like, will it do the, okay, what I meant was if let's say I was doing sleep for 2 seconds, like delay for 2 seconds, right? So delay the program for 2 seconds. Then I was just wondering whether it would output 1, it would delay for 2 seconds and then it would output 2, or whether it would delay for 2 seconds and it would output 1, 2. Like, I just wanted to figure that out, but well, I don't know how to do a delay, unfortunately. How the loop is working till 1e10. So Preetham, what is happening is that C++ is a very, very fast language because it does many optimizations, right? And over here, it clearly saw that this input, this loop is useless. This loop is completely useless, right? But what I can do is actually say I'll output X. Okay, this will also finish instantaneously. Like C++ does a lot of optimizations. Like if I do this, you will see that it almost immediately will print 1e15. I'm pretty sure. Oh, it's not. Okay, it's not. Actually, it's not doing that. That's cool. Okay, let's see. This should take like a decent amount of time, 1e10. Okay, there you go. It does output this. That's cool. Now, what I can do is, okay, you know what? I don't even need to experiment anymore. What happened is basically like we took 1, then we took X. Like it did not output like instantaneously, right? So it did not output instantaneously. So what this means is whenever you don't have cin.tie null, it always clears the, okay, let me take backslash n actually. Let me take backslash n. Let's see what happens again. Okay. We'll solve the problem after this, I swear. Okay. Yeah. So you can see that again, whenever we don't have cin.tie null, it keeps the buffer flushed, right? So it always flushes the buffer. So yeah, if you use endl, it also flushes the buffer. But if you don't have cin.tie null, it still flushes the buffer. So you need to keep that in mind. So yeah, just keep in mind that for interactive problems, it would be better to remove FastIO and also use endl instead of backslash n, right? Use endl, not backslash n. Let me just write this so that it's simpler. And yeah, there you go. Okay, fine. So I guess we can move on then. Okay, cool. Let me discuss a problem then, because we haven't gone without solving a problem for too long. So yeah, let's start with the first problem. Okay, so in this problem, we have this problem is called interactive. This is an interactive problem. This is called hidden permutations. So the problem says that the jury is whoever is judging your code basically, has a permutation of permutation P of length n and wants you to guess it. So he has a permutation and he wants you to guess it. And for this, the jury created another permutation Q of length n. So to guess this, they have another permutation Q. And initially Q is an identity permutation. An identity permutation is just 1, 2, 3, 4, 5, 6, 7, 8, and so on. Right. So it's just 1, 2, 3, 4, ... Now, what you can do is you can ask queries to get QI. So you can ask queries from the judge to get the QI value. So you can ask QI for any I that you want. So any I that you want, you can ask a query, right? So for example, let's say I have n equal to 5. That means my Q will be 1, 2, 3, 4, 5. Now what I'm saying is I'll ask a query for 1, right? So that would mean that I output question mark 1. So you can see that in the format, they say to get the value of QI, output the query in the format question mark I. And this will tell you the value. This will tell you 1. Now, what they're saying is, you can ask this query, and after each query, the jury will change Q in the following way. At first, the jury will create a new permutation Q prime of length n such that Q prime of I equal to Q of Pn. Okay, I know this is sounding a bit complex, but it's not actually. Let me explain. So what happens is, let's say we have a permutation. Let's take the input. We have 4, 2, 1, 3, right? So in the sample input, we have 4, 2, 1, 3, 4, 2, 1, and 3. Now, let us say that we take Q. This is P. This is Q. And initially we have 1, 2, 3, 4. Now, what happens is, let's say I'm doing a query, QI, and I here is equal to, let's say, 2, right? Then what I'm going to get is, as an output, I output question mark 2, and as an input, I get 2. I get the input as 2, right? Okay. Now, what happens after this is that you take, for every QI, you take Q prime of I is equal to Q of Pi, which basically means that Q prime of I, which is a new Q. So here, let's say Q prime, this is Q prime over here. And for the first index, we get P of 1 is 4, right? So I take Q of 4. So here I take Q of 4, over here I take Q of 2, I take Q of 1, and I take Q of 3. Now Q of 4 over here is 4, right? Q of 4 is clearly 4, Q of 2 is clearly 2, Q of 1 is clearly 1, and Q of 3 is clearly 3. Now, this is our new Q value. So the new Q value is equal to 4, 2, 1, 3. Now, let us do this again. So let's say I now ask a query for, let's say, 4. So that will output 3 for me. And then it again does the same operation. So it says I'll take Q of 4, Q of 2, Q of 1, and Q of 3. Now, Q of 4 over here is clearly 3, right? So it's over here 3, because this is a new value of Q now. Now, Q of 2 will be just 2, Q of 1 will be just 4, and Q of 3 will be 1. Now, let us do this again and see what happens. Let's just do this once more and see what happens, right? So over here, if I do this once more, I take the 4th value, Q4, which is 1, and I take Q2, which is 2. I take Q3, which is Q1, which is 3, and I take Q3, which is 4. Now I get back to 1, 2, 3, 4. Right. So this is basically what happens. Okay, cool. So what happened here is that we initially had something and then it just keeps rotating, right? So it just keeps rotating until you get back to the first value. So let's actually see how it rotates. Let's actually look at how it rotates over here. And the rotation works like this. Basically, if you have 1, 2, 3, 4, then what is happening is that, well, when you rotate, you take this cycle. So each permutation, if you take a permutation, each permutation actually has a cycle, right? So each permutation actually has a cycle, which basically dictates how the permutation changes. So over here, the cycle is 1 to 2. 1 to 4, 4 to 3, and 3 to 2. So this is our cycle basically. And from 2 to 1, right? So you can see that if you have any permutation, you can take whatever permutation you want. You can break it into a cycle. Now, let us say we have 1, 3, 5, 4, 2, right? So let's say we have 1, 3, 5, 4, 2. Now over here, 1 is a cycle in and of itself because 1 is continuously going to 1, right? So this is just a cycle. Okay, from 3 we go to 4, from 4 we go to 2, and from 3 we go to 5, from 5 we go to 2, and from 2 we go to 4, right? And well, this is another cycle, right? So this is another cycle, like you go from okay, actually sorry, I keep messing this up. From 3 we go to 5, from 5 we go to 2, and from 2 we go to 3, and 4 is another cycle. So 4 just cycles back to itself every single time. So this can be broken into a cycle of 1, 3, 5, 2, and 4, right? So these are the cycles here. Okay, please explain the procedure again. Yeah, sure. So the procedure is that you first have the input, right? So you have the input of the number. So you have a number. Then you can ask a question. You can ask a question for the index in this identity permutation. So basically you have a permutation Q, which is just 1, 2, 3, 4. Then after you ask a query, what happens is that the jury will create a new permutation such that Qi equal to Qpi. So for example, what will happen here is that we take Qi, so Q of 1. Over here, this will be Q of 1, right? So this will be Q1. So Q1 will be equal to Q prime of 1 will be equal to Q4. And that's because Pi, P4 is that, right? Okay, let me show you. So what happens is we basically take Q4 and we take Q2 and we take Q1 and we take Q3, right? So we take Q4, Q2, Q1 and Q3. Now Q4 is 4, Q2 is 2, Q1 is 1, and Q3 is 3, right? And I'll do this again. I'll take Q4, okay, 1 second. I am logged out apparently, but it should be fine. So I take Q4, Q2, Q1, and Q3 again, which should make it so that we have Q4, which is 3, Q2, which is just 2, Q1, which is just, Q1 is just 4, and we have Q3, right? Q3 will be equal to 1, right? And if we do this the final time, you'll see that we get basically the same thing. We won't get the same thing. I mean, we'll get basically if you take this Q4, which will be 1, Q2, which will be 2, Q1, which will be 3, and then the last value has to be 4, right? So this is the cycle thing. So this is the permutation basically. Yes, Banu. In a lot of permutation problems, you will notice this pattern that they ask you for the cycles, right? Now, they are asking that within 2n queries, you need to guess P. So you need to guess the permutation P within 2n queries. So how can we do this? That's the question. Okay, if anyone has any idea, you can let me know. Try to think about this for a second. So yeah. Okay, I'll give everyone a hint, by the way. The hint is that, again, these cycles are very, very important, right? These cycles are extremely important. And you need to somehow use these cycles to figure this out. P array is not changing. No, man, P array does not change at all. So this is what you have to guess. The original P array is what you have to guess. And the P array does not change at all. That's exactly right, Banu. We can find self cycles by asking the same query again. Yes, that is correct, Banu. For example, let us say that we did a query for index 2, right? So let's say we did a query for index 2. Then after the next iteration, notice that it stays the same, right? So the queries, the array stays the same. So yeah, there you go. So you can in fact do that. That is possible. 2 queries per element, 2n. So Nikhil, that is kind of correct, but it's not exactly right actually. So it's not 2 queries per element rather, but you need to think about this a bit more. Okay, let us say I will give you a very simple idea. Let's say we have 2, 1, right? So we have only n equal to 2. I have n equal to 2. Then in this case, how can you find the answer? Initially, Q will be equal to 1, 2. And P can be equal to either 1, 2 or 2, 1, right? P can be either 1, 2 or 2, 1. Now, if P was equal to 1, 2, then what will happen? Can someone tell me what will happen to Q prime? What will Q prime be equal to? So if I did a query, if I did any random query, yes, Sukhendu, it will stay the same, right? Exactly, Shush. So it will just be 1, 2 again. Now, let us say that it was actually 2, 1. Then what will happen? Yes, Swaraj, you are exactly right. But if it was 2, 1, then what will happen? What will happen if it was 2, 1? It will become 1, 2. Exactly right, Val. So Val is exactly right. So what will happen is we'll get 2, 1, right? And Nikhil was also correct. Wait, what? I mean, if I took 2, 1, then what will happen? After for Q prime. Okay. No. 1, 2 is for the first one. Okay. We need to find the answer for Q, like this one, second one. That will be 2, 1, right? Yes, Yash. So we'll take Q of P1, which will be 2, and we'll take Q of 1. And Q2 over here is 2, and Q1 over here is 1, right? Now, actually, try to think about how we can find the answer. Like for an array of n equal to 2, how can you find the answer? Yes, Banu, you are exactly right. If you get different answers from a judge for the same query, then they are in fact a part of the cycle. That's exactly right, Banu. So what Banu said is exactly right. So what will happen is, let's say we have a cycle. Let's say we have a cycle like 3, 1, 2, right? So if you have a cycle like 3, 1, 2, let's say P equal to 3, 1, 2, and Q equal to 1, 2, 3 initially, right? So it's 1, 2, 3 initially. Now, if you query for 1, then we'll get 1, right? So what we can do is actually discard this. We can discard the first query because, well, that's of a different array, right? So that's like 1, 2, 3. That's pretty different. So I can discard the first query. Now, what I can say is for the second query, when I do a second query, then we'll get, well, what will we get? So we'll get 3, 1, and 2, right? So for the second query, we get 3, 1, and 2. Then what I'll say is, well, I'll take 3. So I'll say I'll take 3. And so that will be my value right now. So I'll take 3 as my value, right? One value is 3. Now I will take the query of the same value again. I'll take the query of the same value again. Now what will happen is we'll get for 3, 1, 2, we'll get 1. Like, okay, I'll take Q3, which is 2. And then 3 and, okay, 2, 3, 1. Yes, exactly. So we'll get 2, 3, 1, right? So if I query the same index again, I'll get 2. Now, if I get the query it again, I'll get 1, 2, 3 now, right? So I'll be getting 1, 2, 3 now. And notice that again, it's 1, right? So over here, it's 1. So 3, 2, and 1 are my values, right? 3, 2, and 1 are my values. Does this make sense? 3, 2, and 1 are my values because, well, these are the part of a cycle, right? Now, let us actually say that we have 4 values. Let's say we have 4 values now. I will repeat this summon with a better example. Let's say I get 3, 1, 3, 4, 2, something like this. And initially I'll have 1, 2, 3, 4, right? So I'll take 1, 2, 3, 4 initially. Now what will happen is when I take the first query, let's say I query at index 1, that will make it so that the array becomes, well, it will become 1. So 1 will stay the same. Now I'll take 3, 4, and 2. So after the first query, Q will change like this, right? So it will become 1, 3, 4, 2. Now, I initially queried for 1, I got 1. I'll query for 1 again, I got 1 again. Now I can say that, okay, since 1 hasn't changed, it has to be part of a cycle, right? So it has to be part of a cycle because 1 has not changed. Okay, now what I'll do after this is say, okay, I can just go to the next value then. So since this is equal, I can just go to the next value, right? So I can just go to the next value. So I'll go to the next value and I'll take query for 3. So after I query for 1, so I first queried for 1, this happened. I queried for the first index again, and then it will change again, right? So it will change again to what? So let's see what it will change it to. So it will be changing to 1 again. So 1 will stay the same. So we'll take P3, which is 4, P4, which is 2, and P2, which is 3, right? So P2 will be equal to 3. So I get 1, 4, 2, 3. Now, let us say that I do a query for 2. So I do a query for index 2, right? That will give me 4. So that gave me 4. Now, after that, what will happen is I get 1. I do the operation again. I get 2, and then I get 3, and then I get 4, right? So I do the query again. I get 2. I get 2 this time. Now, what will happen is the thing again becomes 1, 2. It becomes, 1, 3, 4, and 2. Right. Now I query for this again and I get 3. I get 3 over here. So I do this again and I get 1, 4, 2, 3. And I query for this yet again. And what happens when I query for this yet again is that this value matches with the previous value. Right. So this value matches with the previous value. I already have this. So this is the beginning of the cycle. Right. So the beginning of the cycle is this 4. Does this make sense to everyone? Is this clear to everyone? Any doubts here? Okay, cool. Yeah. Yes, the beginning of the cycle is in 4. Is 4. Yes. Swaraj says so. 1 is in self loop. Yes, 1 is in fact a self loop. 3. Okay, Aman, by the beginning of the cycle, what I meant was that it starts at 4, right? So initially we queried 4, then we end up at 4 again, right? So that's what I meant. Like 3 is the actual value that's supposed to be put here, but that's not what I'm talking about currently. What I'm talking about currently is, I'm just looking for this value, right? I'm just looking for these values, yes. So in this cycle, we got 4, 2, 3, 4. Which means that 4 is the beginning. Like 4 goes, like I'm going back to the beginning, 2, 3, and I'm going back to the beginning, and so on. Okay, fine. So this is how we can find a cycle. Now we have figured that out, right? So we have figured that out. Let's just implement that. Okay, actually, I may show you the solution and then we'll implement it again later. So this is in Python, but this should still be easy to understand. So what I'm doing is I first have the permutation, right? So I first have the permutation. Initially, everything is -1, which just represents that I don't have anything there, right? So -1 represents I don't have anything there. Then what I say is, if this value, if the current value is equal to -1, then I take current of query, like current equal to query of I, right? So current equal to query of I. So let's dry run this with this code. Let's just dry run this, because otherwise, like if we implement this from scratch, we'll not be able to like go through other problems. So let's just do this right now. Okay. Now we'll take this 1, 3, 4, 2 again. Let's just take this 1, 3, 4, 2. Now let's see what happens. Initially we have -1, -1, -1, and -1. So for the judge, query Q is currently 1, 2, 3, 4, right? So Q is currently 1, 2, 3, 4. Now what the judge will do is, well, I am asking for query of I. Okay. Now one thing in general, when you are doing a query, interactive question or something like that, I'd always suggest you to do this. I always suggest you to, first of all, comment this out. Obviously that's that. But another thing that I suggest you to do is say, I'll define a void query function. I can define void query of, let's say, int I, right? So I want to query for index I. Now, what we can do is say cout question mark and I. And I can say, I can also output endl here. Then I can say int x, c in x, and I'll say return x, right? So what this does is it just, okay, sorry, not void. This would be int. So what this does is it's pretty simple. It just takes the query and it returns it, right? So I can say int first index equal to, for example, query of 1, right? So I can just do this. So this will be very helpful for you if you are doing this. And the another thing you can do is, let's say you might query the same index multiple times. So let's say you might query I multiple times. Now what you can do is say map intent MP, and you can say MP of x, MP of I is equal to x. Then you can say if MP dot count, you can do count if you want, like if you are using C++ 17 or something, you can use count. Or if MP dot contains I, return MP of I. And there you go. Right. So this query function also makes sure that you don't query the same index multiple times, which helps a lot, right? So this helps a lot. Obviously, don't do this in this problem. In this problem, the query changes. like the input of the query changes every single time you query. So don't do this in this problem, but you can also do this. This has many exciting possibilities. So you can just do query and you'll probably never make a mistake, right? Like if you accidentally, let's say you're doing this multiple times in your program, then each time you have to see out this, then each time you have to take input and all of that. Now you can just simplify all of this by just taking a function like this. Okay, cool. So yeah, that's nice. Okay, then. Now let's go back to the solution over here. So this is what I'm doing. I'm just doing this in Python as well. And I'm also making sure to flush this. Okay. Now, what I'm getting is basically over here, I'll do a query, right? So over here, I'll be initially doing a query. And in this query, I'll get P. I get P equal to 1342, then Q is equal to 1234. So this is Q. Now, when I do query for 1, so if P of I equal to -1, then I'm saying do this. So here currently for the first index, it is in fact -1. So I'll take current equal to query I, which would make it 1, right? So query of I would be equal to 1. Now I'll say while P of current equal to -1. So while the next value is a -1, keep going to the next value is what I'm saying, right? Okay. So what I'm saying is current equal to query of I, which would make it 1. Now, while P of current equal to -1. So while P of current equal to -1, I will say, okay. Over here, P of current would be just P of 1 again, right? So I'll say current equal to query of I, and while P of current equal to -1, I'll say P of current equal to query of I. Okay. Now, the reason I'm doing this is the reason I'm taking a dummy query over here. So I'm saying query I, and then I'm taking P of current is equal to -1. Then I'm doing this again, right? So I'm doing this again if P of current equal to -1. And I'll explain this in a second. But let's just accept this for now. I'll accept this for now. And let's see what happens. So initially I take current on line, okay, it doesn't say the line number. So over here I take current equal to query of I should be 1, right? And the array changes. The array changes to 1342. Now I'll say while P of current, which is currently 1, is equal to -1. So over here it is in fact currently equal to -1 because I haven't changed the permutations array, right? So while P of current equal to -1, P of current equal to query of I. So what I'm saying is P of current equal to, so basically P of 1 is equal to P of current, which is equal to current equal to query of I. So now I'll take query of I again. So I'll take query of 1 again, which should still be 1, right? So this would still be 1. So what will happen is this will say current equal to 1, and it goes back and it says P of 1 is equal to 1. Now this changes to 1. Now that value is correct. We can verify this, right? So what I did was I took the query again. And while the next value of the cycle is -1, I'll keep going to the next value, and then I'll keep changing this value, right? So that's my idea. Okay, now let's try this again. So then I'll go to the next index. So after I query the second time, this will become 1, 4, 2, 3, right? So this will become 1, 4, 2, 3. Now at the second index, let's see what will happen. Now I say current equal to query I. So I'm querying for this value over here. Now I'll get what will I get? I'll get current is equal to 4, right? So I'll clearly get current is equal to 4. Now after I do current equal to 4, what will happen? Well, I'll take while P of current, P of 4 is equal to -1, right? So while P of 4 is equal to -1, can you show C++ code or explain? Yeah, no, sure. You know what? I'll just convert this to C++, make sure it works, and then I'll submit it, and then we can continue. Okay. I'll say intent, cint. I'll say in P of n, mem set P comma -1. Okay, I'll also return x -1 just to have it as like 0-based indexing. Okay, I'll say mem set P -1 size of P. Okay. Now I can say for int I equal to 0, I less than n, I plus plus. I'll say if P of I is equal to -1. So if P of I is equal to -1, I'll say int current equal to P of query of I, right? So I'm saying query of I. Now while P of current not equal to -1. While P of current is equal to -1, I'll keep repeating this. I'll say P of temp equal to current, let's say temp equal to current. Then I'll say current equal to query of I again, query of I again. I'll say P of temp equal to current, so equal to current, and current equal to, okay, I don't need to change current actually. P of temp equal to current. Yeah, this sounds about right. Okay. Now what I can do is for int I equal to 0, I less than n, I plus plus, C out PA. And I'll take +1 just to make sure that it's one based indexing again. Now let's run this, make sure this works. Okay, my input will be 4213. So my input will be 4213. Let's make sure this works for the input 4213. Okay, let's see what I get. Okay, initially I have 4213. Now I will enter 4. It's asking for index. Okay, actually I need to output query +1 now, I think. Okay, that's why you always test your code, just in case you make a mistake. Okay, cool. So I'll take 4 values. I get what's the first index. I'll say it is 4, right? So I'll okay. Actually, wait. No. Am I bad? So I have 4 values. Initially, I have Q equal to 1, 2, 3, 4, right? Q equal to 1, 2, 3, 4. I take current as 1. So I'll take current equal to 1. And it's again asking what's at 1, right? So after I do this once, I get 4, 2, 1, 3, right? So I get 4, 2, 1, 3. So it's asking for me again, what is at 1? I say 4. It's asking me what is at 1 again. Now over here, what will happen is, well, the next thing that we are going to get will be 3, 2, and 3 will be that first thing, I guess. Yeah, 3 will be there. 2 will be staying as 2. Over here, I'll get 4. And over here, I'll get 1. 3, 2, 4, 1, right? So at 1 again, I have 3. Now, if I do this yet again, let's see what we get. So I'll get 4th index, which is 1, 2, and I'll get 3 and 4, right? So I'll get 1, 2, 3, and 4. Okay, cool. Now it's asking for the first index again, and I'll say it is equal to 1, right? So I'll say this is equal to 1. And now it asks for the second index. So what happened was basically, okay, let me actually input the entire thing. So the second index I have 2. Again, I have 2. So yeah, okay. It says 4213. Yeah, it does say 4213. I should not output an endl, but rather a space. But yeah, you can see that it outputs 4213, and that is correct, right? So 4213 is in fact our input. Okay, now let me explain this. Now, what was happening is basically, after I submit this, I'll explain. Once again, sorry. I don't want to make sure, I just want to make sure that I'm not submitting wrong code. That's like, I'm not explaining wrong code either. So let me submit this, make sure it works, and then we'll continue. Okay, that's not a good sign. Oh, it's saying wrong answer on test 1. I don't know why. Oh, am I supposed to output an exclamatory mark? Yes, I am supposed to output an exclamatory mark. Okay, there you go. Okay, my bad. Okay, let's try this again. So I guess you can witness firsthand what all stuff you need to do. Oh, this is still wrong answer for test 1. What? How? Huh, okay. Okay, let me think about this. Why is this still wrong answer? Pn plus 1. No, that shouldn't matter because I'm converting this to x minus 1, right? So I'm asking the query as I plus 1, and then I'm converting this to x minus 1. So I'm not sure why this is going out of bounds. So it might actually be in the second test case. So I'll just try that out as well. Oh, wait, I figured it out. I'm not even taking the test cases. I'm not taking input of the test cases. That's obviously why. Okay. Wow, so many mistakes to make. Okay. Let's do this yet again, and hopefully it works for hopefully it works this time. Let's see. That's still not a good sign. Let me reload. Test 2. Okay, there you go. Test 2. If it's wrong answer on test 2, I'll be a bit mad. I'll be honest. Okay, what? Okay, that's weird. Oh God, okay, this is not necessary at all. Okay, there you go. I am pretty sure it works. So since it's running on test 17, I'm pretty sure it works. So that should be fine. Okay, there you go. It does work. Okay. Now, yeah, this is the solution basically. Now, what was happening is again, we are first of all taking input of all these things, right? So we are taking input of this. So yeah, so when we had, let me go back to that other thing. This is the thing that we were discussing previously. Yeah, I know some of you might have understood the code already, but I'll still explain this. But basically what's happening is that again, we are taking, for one, I hope this is clear. So what I did was I first took current equal to 1. And while P of current is not equal to -1, so while P of 1 initially it was -1, so I took input of 1. So I took input of 1, then I took input of 1 again, then it immediately stopped, right? So then it stopped afterwards. Now, what it would do is next, okay, let's see. Let's actually run this. Let's actually run this with the same thing. Okay, so let us say there's one test case. There are 5 elements. Oh, actually, there are only 4 elements. So our input is, okay, our input is going to be of size this, right? So this is going to be size 4. So for 1, it is asking what's the value. I'll say 1. So for 1, it's asking the value again. I'll say it's 1 again. Then it goes to 2, right? So I ask for the query. I say query of I is equal to 1. And then it takes P of current, which is P of 1 is equal to -1. So while P of 1 is equal to -1, I say temp equal to current. So temp equal to 1 here. Temp will be equal to 1. Current will be again equal to 1. Right? Because I know that when even after I rotate this, even after I do the cycle thing, this will come back to 1. Right? Then I'll say P of 1 equal to 1, which is correct. Right? So far it has been correct, which is very nice. Then after that, it asks for 2. So the moment this happens, it says P of 1 is not equal to -1 is false. So it stops, right? So it stops here. And after that, it asks for 2. And after the first query, this was after the first query, this was the state. And after the second query, this is the state. So now I will enter 4. So I'm entering 4, right? So what will happen is this is now 1. Now I'm entering 4. So current will be equal to 4. And we know that P of 4 is equal to -1. So that's fine. So since P of 4 equal to -1, we have jumped to 4 over here. Current equal to 4 now. So current is pointing to this index. Now it's asking what is the thing for 2 again. So what's the thing for 2 again? So for 2, what will happen? So after we do this, the next iteration would be 1. Then it would be 2, 3, and 4, right? So it will be 1, 2, 3, and 4. Now what I'm saying is, well, this will be equal to, after I take 4, the second index will be equal to what? Well, that's just 2, right? So I'll just say it's equal to 2. Then after I do this again, I know for sure, since we have already done this, since we have already figured this part out over here, we know that this is equal to 1 second. Just give me a second. Oh, what? Why is this not writing? Yeah, let me just move zoom. Okay, zoom is not letting me see things. Okay, fine. So this will be 1342 now. So after this one, this will be 1342. Then after that again, that will be 1423 and so on, right? So currently we are at 1342. So it asks what's at 2 again. I say 3. So I say the answer is equal to 3. Okay. Then it asks what's at 2 yet again, and I say the answer is equal to 4. Right. So it says I say the answer is equal to 4. Then it says 1342. And that is in fact my thing. Right. So that is in fact my thing. Now let me explain how this works. I know this sounds a bit like magic because it's just asking the same index multiple times and somehow it figured out the entire thing, right? So let me explain how this works. But basically what's happening is, okay, let's start over. So for 1, I don't think I need to explain, right? So for 1, I'm pretty sure it's clear for everyone. I query once again, and I know this is the end. So I stop over here. Now, after this is done, I get a pretty random state, right? So I'm at a pretty random state over here. But what is going to happen is that we know we are at a cycle. We know for sure we are at a cycle, right? So start from P equal to -1. Yeah, but 1 is pretty clear though, right? 1 is just querying the same index twice and we figure it out like that. like if I explain the second cycle, you will immediately understand the first cycle as well. That should be clear. So don't worry about that. We'll also take one more example if this is not entirely clear. Don't worry about that. Okay. So initially I say that, okay, we look at a cycle, right? So we'll be looking at a cycle. And what I'm going to say is in that cycle, so let's say I am at 1342, then I can say that at 3, right? So at 3, well, what is going to be the value at 3, right? Okay, let us say somehow I end up at this location. Then what will happen? Well, let's say I'm at this location and I'm querying for 2. So I'm at this array and I'm querying for 2. Then I'm going to get an index of 3. Now I'm saying that start from 3. I'm telling my program start from 3, right? So start from 3 is what I'm telling it. Then I'm querying for the same index again, right? And this time I say move from 3 to 4. So I take the query over here. I take current equal to query of 5, and I'm saying that start from this index. So this index will be the first value. So I'll say, okay, at 3, I'm querying for 3, go to 3, and at 3, put the value of 4, right? So that's what I'm telling it. Now, how exactly does this work? How exactly does this work, right? So that's pretty confusing, right? Like, how does it know from 3 that I should go that, right? I don't understand how this works. But basically, the thing is, notice that after I query for an index, right? So after I query for an index, I go to that index, but that index comes to me. Okay, let me explain this with another cycle. Let's take the most random cycle. Let's say 5, 3, 1, 4, 2. Right. So, okay, actually, let me take 1, 2, 4 so that this is a 5-length cycle. Now, what I'm saying is, let's say I query for 5. If I'm querying for 5, then what will happen is I'm starting from here. I'm saying start from this index. But what happens after I query? Well, this is my p value. My p value is this. My q value would initially be 1, 2, 3, 4, 5. Now, after 1, 2, 3, 4, 5, when I queried for the first time, it's going to become 5, 3, 1, 4, 2. 1, 2, 4, right? So it's going to be 5, 3, 1, 2, 4. So this is going to be the second state. Now, what I'm telling it is that query for, if I'm at 1, I'm saying, well, 1 will be my first value itself, right? Like directly 1 will be my first value, right? Because after that, notice that at 1, what comes? What comes to 1? Well, if I'm going to 1, right? So if 1 is over here and I'm going to 1, then 5 comes to 1, right? 5 is always coming to 1. Like if I'm at 1, like let's take 2. Let's take the value of 2. Then after I query for 2, 3 comes to 2, right? 3 comes to 2 after I query for 2. Now my goal is basically, I'm saying that my goal is after I query for an index, that number should come to me, right? So that number should come to me after I query for an index. Now, how will that work? Well, let's take another example for this. Let's take this scenario. Over here, let's say I query for 5. Now, after I query for 5, let's see what happens, right? So after I query for 5, well, what am I going to get? Okay, I'm actually querying for 1. I'm querying for index 1. Let's see what I get. After this, the permutation will be equal to 4. And notice that the value at 5 is coming to 4. Like value at 5, it's moving to where 5 was. Right? The value at 5 is moving to where 5 was previously. Now over here, the basically the value at 1, over here the value at 1 is moving to where 1 is, right? Now the value like over here when I queried for 1, the value that was at 1, which is 5, is moving to 1, right? Now over here the value that was at 5 is moving to where 5 was. Now after that the next value will be equal to 4. So this is 4, and after that I'll take 1, and then I'll take 5, and then I'll take 3, and then I'll take 2, right? Now let me query for 4 again. Now when I query for I'm always querying for 1, but basically I'm just telling you the location. So say the location is 4, right? Then what's happening? So well, let me see. When I query for the location 1, I get 3. Right. So when I query for location 1, I get 4, but at 4, I get the position like the value of 3, right? So 3 moves to 4 because, well, that's how it works. So I'm saying that in the permutation, 4 will be calling for 3, right? Like I take Q of PI. So I take Q of PI, which is basically saying Well, I take 5 over here and I take the fifth index, right? I take the fifth index. Actually, wait 1 second. I made a small mistake. I think, just give me a second. Okay, at 5, I take the position of 4. Okay, 4, and then that will be 1, 5, 2, and 4. Okay, that's correct. That's correct. Okay, now let's do this once again. I will get 2. And then the next value that I get will be equal to 2, 5, and 4, 2, 5, 4, and 1, and 3. 2, 5, 4, 1, 3. Okay. So I was a bit wrong. Actually, 3 doesn't come to 4. My bad. That was a mistake. Let me see what it actually does. So what will happen here after I query for 1 again would be that if I was querying for 1 from this position over here, then I'm saying that, well, the value is equal to 4, right? So the value is equal to 4 over here. Now, well, after I query for 4, let me go to position 4, right? I'm telling it go to position 4. Now, and from that position, I'm saying, well, fill the values. Okay, let me go back to the code. You can see that first I'm querying for that index, right? So I'm querying for that index. Then I'm saying go to P of current. So go to P of current. And if the current value is equal to -1, which means that if it's not filled, if it is filled, then I should not change the value. The cycle is complete, right? So if P of current not equal to -1, the cycle is complete. So the cycle is complete in this case. But if it is not complete, if this current value was in fact equal to -1, then I'll take temp equal to current. So temp equal to current is just saying that temporarily store the value of 4. So over here, let's say I'm querying 1 from here, from this position. Then I'm saying, well, go to the value of 4. So P of current will be equal to -1, temp equal to current. So temp equal to current again basically means that I take temp equal to 4, right? Then I'm saying current equal to query of 5. So that will be equal to 2, right? Now, basically what happened is, again, when I move from this position, like when I take the fifth position, like this cycle is rotating, right? So we know this cycle is rotating. And how exactly is it rotating? Well, you take 4, 4 goes to 3, 3 goes to 5, 5 goes to 2, and 2 goes to 1, and 1 goes to 4, right? So 1 goes to 4 again. Now, how exactly does this rotate now? Well, let's see. Actually, we should take the rotation of the original thing so that it's a bit clearer. So the rotation of the original thing is 5 goes to 4, 4 goes to 2, 2 goes to 3, and 3 goes to 1. Okay, this is the rotation of the original thing, right? Now, I will apply this rotation. I will apply this rotation basically. I'm applying this 5, 3, 1, 2, 4 rotation to this array over here, which basically moves it, right? Which basically moves it. So 4 will end up at, okay, 1 second. So from 1, I go to 5. Yeah. So I didn't finish the cycle. So over here, 4 will be moving to, well, I'll take 2, right? So, I mean, at 4, the position of 4 over here, that is going to 3, right? Okay, I'm confusing this a little bit. Like, we are at 4. Now, what we are going to do is take permutation of 4, and I'll take permutation of 1, and I'm taking Q of P1. Q of P1 is 5, right? So Q of P1 is 5. So I'm taking the fifth value over here. That's what I'm doing basically. So now, again, we are just applying this permutation to this query over here. I know this is a bit, hard to understand. Like, I don't exactly know how to explain this. I'll be honest with you, but I'll try to figure it out, right? I'll try to figure it out. So what I'm doing again is I'm taking this 5. I'm saying that take this fifth position over here, take this fifth position and put it at this location. Now, for 1, I'm saying that, well, take the third position and put it at this location. Now, what happens is when I take this position, when I take 4 over here and I go to the fourth position, right? So when I go to the fourth position, you will see that that will be the next value. When I take 3, for example, let's say I take 3 and I go to the position of 3, right? So this 1 over here, next value is equal to 1, right? So now let me take any random value from this thing. Let's say I take this 4. Well, let's take the fourth position. That's 2. Now at the fourth position, I have 2 next, right? Do you understand like what's happening here? And the reason is because, okay, the reason is pretty much because, let me do this one more time. Let me do this one more time and it will be clear to you. So what will be the next thing? The next thing will be at position of 5, I have 3. At position of 3, I have 4. at position of 1. So at position of 1, I have 2. At position of 2, I have 5. And at position of 4, I have 1. Right. So this is the next value that I have. And let us see what exactly this looks like. Okay, let us take the column. The column is 1, 5, 4, 3, 2, and 3. And notice that from 1, I'm going to 5, 5, I'm going to 4, 4, I'm going to 2, 2, I'm going to 3, and from 3, I'm going to 1. Right? That is my permutation. This is the entire permutation that I had. Now, let me look at the next one. The next one, I have 2, 3, 1, 5, and 4. And now notice that from 2, I'm going to 3, 3, I'm going to 1, 1, I'm going to 5, 5, I'm going to 4. Right? So basically what's happening is that if I'm at a position like 3, then I take the third value. Well, that's going to be the previous value, like the next value, right? So if I take the next one, that's going to be the next value. And this is pretty much happening because all of these are in order right now. All of these are in order 1, 2, 3, 4, 5. Right? So it's starting out like 1, 2, 3, 4, 5. And what happens is when you take the value, when I take the value at 1, I get 5. Right? So when I take the value at 5, when I take the value at 5, I clearly get 5. Right? So for 1, I take Q1 equal to Q prime of 1 equal to Q of 5. Right? So Q of 5 is this one. So that takes the next value. Now from this one, what is the next value? Well, the next value is going to be 4, right? So from 5, I go to 4. Now, and from 4, well, where am I going to go next? Well, I'm clearly going to have to go to 3. Clearly going to have to go to 2, right? Because when I apply this every single time, this is just rotating this thing. This is just rotating this permutation. I know it's a bit hard to see, but we are just rotating this permutation over here, right? So we have 1, 2, 3, 4, 5 over here. Now, this next one is going to be a rotation, right? So I'm going to move through this. So from 1, I go to 5. From 5, I go to 4. From 4, I go to 2. From 2, I go to 3. And 3 to 1 and back to 5, right? So this is the rotation that's happening. And if you look at it column-wise, it should be very clear. It should be very clear this is the rotation that's happening. Okay, does everyone see the rotation, by the way? I know some of the parts is still not clear, but is the rotation part kind of making sense? Does everyone see the rotation? Okay, yeah. So how this rotation happens is again, basically you need to know about permutation cycles for this, basically. But well, after you apply it once, it comes to this, right? It comes to this. Then when I take the fifth value again, that's going to be 4, right? How to understand answer is second column and not other. What do you mean answer is second column? I didn't understand, Sukhendu. Why is it necessarily the second column? It's not always the second column, by the way. Yeah, every column is following this rotation. Okay, yeah. So basically, the values at the value at 5 goes to over here, right? Then if I take the next value, that will be 4. If I take 5 again, that will be 4. If I take 5 again, that will be 2. Then it will be 3, and then it will be 1. Now, okay, let me try to think about a very easy way to explain this. Just give me a second. I'll just try to think about this so that it's easier to understand, right? So I'll just try to think about that. Okay. So, okay, let's just consider 1, right? Let's just consider 1. Then what I'm doing is, first of all, it's 3. Initially, the value is 3. Then what happens is I'm saying the current value will be the value at 1. Right, so the current value I'm saying will be the value at 1, which is just 1 over here. So I initially have 3, and I'm saying that the next value is going to be the value at 1, which is 5. Right, that happens. Now I'm saying that again, after the next rotation, I'm saying again the value is going to be the value at 1. Give question link in chat. Yeah, I'll send the question link in chat. So the value will be at 1 again, and this time notice that it's equal to 5. Right, so this time it's equal to 5. Because all of them are rotating, and basically if you take 1, if you repeatedly keep taking the value at index 1, right? So at index 1, there is initially 1. Then at index 1, the next time, well, we have 5, right? Because clearly we moved this 5 over here. So we said the position at 5 should come to me, right? So this will come over here. Then I will do this rotation again. So I will do this rotation through the cycle, which will be 5, 3, 1, 2, 4. This is our cycle, 5, 3, 1, 2, 4. And if I perform this rotation, well, what's going to happen is 4 is going to the position of 5. 5 is going to the position of 1. So this cycle basically is 4 is going to a position of 5, 5 is going to a position of 1, and 1 is going to a position of 3, 3 is going to a position of 2, and 2 is going to the position of 4, right? So it's just rotating in a backwards direction. Then if I do this again, notice that from 5, like 5, I get 4, right? So the reason I get 4 is again because I moved this way. Then if I do the rotation again, then, okay, so initially we had this rotation, 5, 3, 1, 2, 4. Then I moved it this way. I moved it this way. So what I would get is basically 4, 1, 5, 3, 2. Right. So I get 4, 1, 5, 3, 2. Then I would perform the same rotation again, because this permutation cycle, applying a permutation cycle, is just rotating through that permutation, right? So again, what will happen is 2 will go to 4, 4 will go to 4 will be going to where? 4 will be going to 5. Okay, 4 will be going to 5, 5 will be going to 5 will be going to 1, and 1 will be going to 3, and 3 will be going to 2, right? So let's say if this is the case. So in the next case, you can see that in fact 2 is in fact going to 4, 4 is in fact going to 5, 4 is in fact going to 5, 5 is in fact going to 1. So 5 did go to 1, and 3 does go to 2, 3 does go to 2, and well, for 3 we get 1, right? So 1 comes back to 3. So 1 comes back to 3, and that's what we get. Okay, is this a bit clearer now? Like this is the permutation cycle over here. This is the permutation cycle. And when we apply a permutation cycle on this, basically we are rotating through that permutation. Does this make sense? We are just keeping, we just keep rotating through the original permutation. We just keep applying it again and again and again. So that's what's happening. Does this make sense to everyone? And yes, I know that this is a bit hard to grasp. Like, I know that you guys probably feel like you understand, but you don't understand at the same time. But I highly suggest taking some examples, like take some examples for this. Let's just take some permutations and notice that, well, the cycle, this is a 5-length cycle. Maybe try various different cycles. For example, you can take 4, 2, 4, actually, no, let's say 4, 3, 2, and 1, 5, right? So this will be 2 cycles, 2 different cycles. So this will be 1 cycle, and this will be another cycle, and this will be the 3rd cycle, right? So there are 3 cycles over here, which could help. You can also take something like 5 over here and 2 over here, so that this is a bigger cycle, right? So you can have 2, 3 cycles, something like that. So just try to take some examples and try to figure this out. Try to work this out with your pen and paper, something like that, and it should become clear. Like again, I know that many of you probably feel like you understand, but you don't understand at the same time. Like, I'll be honest, like I don't know how exactly to explain this, right? Like this permutation cycle thing, that's just going to happen. Okay, Chris says, so applying same permutation Q to Q is equivalent to applying cyclic permutations to 1, 2, 3, 4. Yes, basically that is correct. So when I have 1, 2, 3, 4, 5, and I apply this permutation, well, okay, so actually, basically cycles are, if you follow a cycle, right? If you follow a cycle, you will always get to the original position, right? So whenever you follow a cycle like 1 to 5, well, 1 is ending up at 5, right? So 5 to 4, 5 is ending up at 4. 4 to 2, that's ending up at 2, and so on, right? So whenever you follow a cycle, you'll always end up at the original position. So 1, 2, 3, 4, 5 is kind of like our original position over here, right? Now, after this, when I apply this permutation, I'm just going back to the original, like the permutation that I had over here. So from the identity, I'm going over here. So yes, that is kind of correct. Yes. So we are just applying this cyclic permutation, and the cyclic permutation is just rotating through its cycle. Basically, it's just rotating through its cycle. So let me show you 1 second. So we have 1, 1, 5, 1, 5. And after that, we have 2, 4. Okay, 1, 5, 4. Okay, 1, 5, 4, 2, 3. Now, basically, what we are saying is initially, like over here, this is the cycle, right? This is the cycle that we have. And what I'm saying is just rotate this cycle. Just rotate this cycle and then set the indices to the same value. So 1 is at index 3, 5 is at index 1. So this is index 3, 5 is at index 1, 4 is at index 5, right? And I'm saying the next value is index 5, 4, and 3 is at index 2. Now, let us say that we rotate this cycle. Like we rotate this cycle, then let's see what happens, right? Let's see what happens when you do this. Okay. Now, what will happen is, well, 5 will move over here, 4 will be moving over here, 1 over here, 2 over here, and this. Now, let us notice the new value. So I'll take 1, 2, 3. Okay, actually, I'm supposed to rotate in the opposite direction. Sorry. Like it depends whether you're doing this clockwise or anti-clockwise, right? So actually, I'm supposed to rotate this in the previous direction. So that would be 5, 1, 3, 2, and 4. Okay. So in this case, let's take the indices again. So we get 4, and at index 2, we get 1, at index 3, we get 5, and at index 4, we get 3, and at index 5, we get 2. And notice that that's exactly the value I get, right? So I get the next value as that. So I get 41532, 41532, right? So imagine the index, like the cyclic permutation over here, and you order the indices. Like for each of these values, you put the value, right? Does it make sense? Is this clear to everyone? Please let me know it's like a plus one or minus in the chat. Is this clear to everyone? Again, please do let me know with like plus one in the chat if this is clear. If this is not clear, please do let me know, by the way. Yes, Banu, thank you. So yes, I would suggest you to consider some examples. Now try the cyclic thing, right? So this cyclic thing, I hope will make things clearer for everyone. Like just take just take the cyclic permutation that you have, like write down the permutation and write down the indices. Now rotate this cycle and take the same indices, and you'll see that you go through all of this, right? So that's basically how it works. Yeah, you should do that, Anupam. You should definitely do that. So do try to solve this problem as well. Like I know the code looks pretty simple, right? So this is pretty simple. The code is extremely simple, but still, like the concept is like kind of, you know, the cyclic permutation concept. Like I have studied this before, so I can easily grasp it. But I will try to find some resources for this, by the way. I'll try to find some resources for this, and I will send it to you in the announcements. So after this class is over, I'll send some resources. So everyone should try this on your own. So I'll send the problem link again. Do try this problem, right? And again, consider this method. Like try to take the cycle over here. Try to take 1, 2, 3, 4, 5, the cycle over here, and then rotate it. And yeah, so you can try to figure this out. Okay, cool. So since we are wasting a bit of time right now, I'll just go to the next problem. So we can discuss the next problem, and after that, the rest of the problems can be like your assignment, right? You can try these 2 problems. Okay, cool. So in this problem, we have searching local minimum, right? So this problem says we are searching for a local minimum. Now, this is also an interactive problem, basically. Now, it says that Homer likes arrays a lot and he wants to play a game with you. And Homer has hidden from your permutation A1, A2, A3, dot, 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 AN of integers 1 to n. You are asked to find any index k, which is a local minimum. So basically, a local minimum is when AI is less than min AI minus 1, comma AI plus 1. Okay, let me explain. So let us say we have an array like 1, 3, 4, 2, 5, right? Something like this. Then in this case, 2 is a local minimum because 2 is lesser than 4 and 2 is lesser than 5, right? So it's lesser than both of the adjacent values. So it's lesser than 4 and it's lesser than 5. So it's a local minimum. But let us consider 3, for example. 3 is greater than 1, right? So 3 is greater than 1. So it is immediately not a local minimum. Now, another thing they are saying is that over here, A0 equal to AN plus 1 equal to positive infinity. So this is positive infinity. And over here, the last index is also equal to positive infinity. Okay. You took this problem in level 2. Can you please take other? Okay, I know I did take this problem in level 2, but like most people here are not in level 2, right? I'm very sorry about this, but like, you know, the point is that most people are not in level 2, and this is a very good problem to show why like interactive, like this thing works. Like not interactive, I mean, true or false thing, like how binary search works, right? Yeah. So we can go through this a bit quickly though. We can go through this a bit quickly, and then we can discuss on the problem soon. Okay. Does anyone have any idea for this? Preferably the people who have not solved this before. So how can we find the local minimum? And you are supposed to find this in 100 queries, by the way. So you have at most 100 queries and you can ask for the index, like you can ask for a value, but you can make at most 100 queries. So how can we figure this out? Okay, first of all, we can tell that this has to be like, this has to be binary search or something like that, right? So this has to be clearly binary search or something like that. And that is because, well, we are asked to find any index k, which is a local minimum after at most 100 queries. And well, we only have 10 power 5 values and only 100 queries, which basically means that you have to do this in a very less number of queries, right? So you have to do this in a very low number of queries, which is pretty hard, which basically means that you need to do binary search on this. But how exactly can we do binary search on this? Any idea? Okay, maybe the people who have solved this before, like Sujit or some other level 2 people, maybe you can give hints, right? Like, can you tell me how you would solve this? Like, how you'd approach this now? Because it has been a long time since the last level 2. So, okay. So if it is binary search, first we need to figure out the predicate function, right? Okay. Sujit has in fact gotten the answer. That is correct. Yes. Okay, cool. Let me explain. First of all, we need to find the predicate function if this is binary search. But there is one small issue over here. There's one small issue, which is that, well, it's not sorted, right? It's clearly not sorted. So how are we going to approach this? Well, the thing is they are saying you are asked to find any index k, which is a local minimum. They're asking us for any index, not just a particular index. They're not saying find the first one. They're not saying find the last one. They're saying find any index k, which is a local minimum. Okay. Now, this requires us to understand binary search properly, right? Okay, let me explain. What does binary search do? Can someone tell me? Especially my binary search that I discussed over here. What does this do? Okay, what did we discuss that our binary search does, right? Like we discussed that it has to be the last true or the first false, right? Like the binary search always finds the last true or the first false. So that's what binary search does. So binary search cannot figure out anything except the last true or the first false. So if we are assuming that all of this is true, and all of this is false, then it always finds the last true and the first false over here. But let us say the array is in any random order, right? Let's say the array is like this. We have true, true, false, false, false. And let's say we have true, 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 and false, false. Now, the thing is, let's try to figure out what binary search does, right? So this will be my left bound and this will be my right bound over here. Like actually it will be outside, but okay, let me just put it outside. So this will be L, this will be R. Now, if I take the middle value, what will be the middle value? Okay, it will be this false over here, right? So this will be false over here. And what I'll say is, since this is false, I'll bring my right bound to false. Now, I'll take the middle value again over here. Now I'll say, take the middle value and take this one, take this thing over here, L. And actually, okay, this is false. So I'll say, take the R and move it to middle, right? So I'll take R and I'll move it to middle. Now, I'll say, well, take the middle value yet again. Take the middle value yet again. That will be like true or something. And I'll say, well, bring this true, bring this thing L over here to 2. That's what I'm going to say. Now, notice that we end up at true false because R minus L now is greater than 1 is false now. So we end up over here. Now, if you notice properly, well, we end up at a true and false, right? So we end up at some true and false. And this is always true. No matter what, the binary search will always end up on some true and some false, right? So if you have, like, let's say this is the last value and this is the last value, like this is the entire array, then we know that everything before this is true and everything after this is false, right? So no matter what there is in the array, like even if the array was empty, we'd have some values true and we'd have like the array ends over here. There's an empty array over here. And then we have false, right? So what our binary search will do is it just ends up at L and it ends up at R, right? That's it. It ends up at L and then it ends up at R. So that's basically what our binary search does. So our binary search Well, it always finds a true and a false. So that's our idea. So our idea is that, well, we can use true and false to figure out our answer, right? So binary search always ends up at some combination of true and false. So over here, this is true and false. Over here, this is true and false. Any true and false will do. Now, what we can do is just say, well, apply this binary search, except that I will do it such that a peak value will be true, like a peak value, and then the next value, if it's false, then it means that this is the peak value, right? So if I have a true, and then I immediately get a false, this is a peak value. That's what I'm going to define it as. Then in that case, I can say, what I can say is just take a of I less than a of I plus 1. I'll just say this. I'll just say a of I less than a of I plus 1. Now, one second. It has to be strictly lesser than. Okay. So it has to be strictly lesser than. So I'll just say, well, ai less than ai plus 1. And now let's see what happens, right? Let's see what happens. Well, if I do a binary search now, well, I will get my predicate function as something like this, right? So I'll get my predicate results as something like this. Now, let's say this is like 1, this is like 2, this is like 1 again, right? In this case, notice that this is true, right? So like this is clearly true because, ai less than ai plus 1 is true over here. Over here, actually, it is false. Okay, now one second. Let's actually say ai minus 1 less than ai. Okay, let's do this. This would be better. So if I take this, if I take ai minus 1 less than ai, then this will be true. This will also be true because, well, over here we know that we have negative infinity. So positive infinity. They have said that it has to be positive infinity. We'll be taking greater than, by the way. So if I take infinity, this will be greater. So I'll say that for 1, this is true. Then for 2, well, this is going to be false, right? So let me erase this. Let me erase all of this. It's going to be false for 2 because clearly 2 is, well, greater than 1, right? So ai minus 1 is greater than ai is false over here. So I'll take 1 lesser than 2. Then I'll say over here, this is greater. 2 is greater than 1, right? So 2 is greater than 1 over here. So over here for 1, this will be true because 1 is greater than the previous value, right? Now, now I have true, false, true. And over here, let's just say the array ends, in which case we'll have infinity over here. We'll have positive infinity over here. So for this value as well, this will be true, right? So this will be this will be false over here, actually. Yeah, this will be false over here because this is not in fact greater. So this is false. Now, basically, we can say that if I get a true and it is immediately followed by a false, then it is actually so far it was decreasing, and at the next value it is increasing, right? So far, if I have positive infinity greater than 1, so this is decreasing, right? So if I have ai minus 1 greater than ai, then it means that at the previous index it was decreasing. And if the next value is false, then it means at the next index it is increasing, which clearly means that I'm a local minimum, right? Okay, is this clear to everyone? Does it make sense? Okay, I hope this makes sense. By the way, please let me know with a +1 in the chat if this is clear. But yeah, so if I take basically ai minus 1 greater than ai, then what's happening is that, well, I'll take the previous value, right? And the current value, I'll see if the previous value is greater. If the previous value is greater, then I'll get a true. Then if I get a true, that means that currently I'm decreasing, right? So from previous value, I know I decreased. Then if I get a false, I know at the next value I'm increasing. Okay, please let me know in the chat with a +1 if this is clear, by the way. If this is not clear in any way, please do let me know right now. If you have any doubts at all, you can let me know. Okay, cool. Now let's see how we can implement this. Let's see how we can implement this with the query thing. Okay, so first of all, I'll take int type. So I'll see out q, question mark, sorry, and I'll output I. And so basically I'm saying ask the value for I, right? Now I will say see out. I need to take input. I'll do that in a second. Question mark. And I'll output I minus 1. Now I'll take int x, c in x. I'll take int y, c in y. Now what I can do is say if I minus 1, I'll just take int y outside. If I minus 1 is actually less than 0, right? If I minus 1 is less than 0, then, okay. Actually, we need to convert this to, okay, this is in fact 1-based indexing. You know what? Let's just keep it as 1-based indexing. So if I minus 1 is less than or equal to 0, I will say y equal to negative infinity, right? So I'll say y equal to actually positive infinity, my bad. So y equal to positive infinity. Otherwise, I will output the query. So otherwise, I'll see out question mark and I'll output I and I'll say C in 1. Okay, now I'll take or I plus 1 greater than n. So in either case, like I can have n outside globally. So I'll have int n like this globally and I'll do this. Now I'll repeat the same for x, by the way. So I'll just do the same for x. Okay, now over here, just one small difference is that I will be outputting I minus 1, right? So if I minus 1 less than or equal to 0 or, okay, or I minus 1 greater than n. So if I minus 1 less than or equal to 0 or I minus 1 greater than n, over here, if I less than or equal to 0 or I greater than n. So x equal to infinity. So this is my query value. So this is my query index. If it's out of bounds, I take infinity. And otherwise, I'll say I minus 1. I'll do the same for I minus 1. And I'll do this. Now I'll just return. Well, this is the previous value. So I'll return y greater than x. Right. That should be it. Okay. Now what I'll do is other test cases. Okay. There are no test cases. So I'll take int n, c in n. Then I'll say, okay. Okay, I shouldn't take int n because this is global. So what I'll say next is take int b, int l, okay, int l equal to 0 and r equal to n plus 1, right? So r equal to n plus 1. We know that we take l and r as 0 and n plus 1 because 0 is the search space begin, which is 1 minus 1, and r is n plus 1, which is the n plus 1, right? So ending of the thing plus 1. Okay, so I'll say while r minus n greater than 1, if query of I minus 1. Yes, we can do that, Sujit. You are exactly right. We can, in fact, do that. So I'll take m equal to l plus r by 2. So I'll take query of m minus 1 less than query of, okay, if query of m minus 1, okay. Query of m minus 1 would be like, actually, this is going to return whether this is increasing or decreasing, right? So I'll take query of L and not query of m plus 1. Okay, query of m and not query of m plus 1. So I'm taking the middle value. I'm saying, is this decreasing now? And I take the next value and I'm saying, is this increasing now? Right. So if I take query of m, this tells whether it's decreasing. So if it is decreasing and the next value is increasing. So if the next value is not decreasing, but the current value is increasing, the current value is decreasing, next value is not decreasing, then in this case, I'll say cout m and I'll say return. Right. So that's it. Return 0. Okay. This should basically be it. Now I'll take a map like Sujit suggested. We can take a map now. We can take a map for queries, QS, I'll say. And I will say when I take input, I'll say if QS of I not equal to the QS dot contains I, basically. Okay, QS dot contains I. Then I'll say, well, x equal to QS of I. Right. Otherwise, I'll take this. Otherwise, I'll say, see out this thing. Okay. Now I can do the same over here. You have QS dot contains I minus 1, x equal to QS of I minus 1. And I'll do see out I minus 1. And over here, after I take input, I'll say QS of I is equal to x. Right. And similarly over here, this will be y, by the way. This will be y. And I'll say QS of I minus 1 equal to y. Okay. So again, let's just make sure this is correct quickly. So I'll say if I less than or equal to 0 and I greater than n, I'll take infinity. I'll do the same over here for I minus 1. Now, if it contains I, then I'll say x equal to QS of I. Right. Now I'm saying that otherwise take the input and then set the value. Right. So take the input and set the value. Okay. Now, actually, what I can also do is take input directly like QS of I like this. I don't need x, actually. I don't need x at all. But you know what? This would be simpler. Let's just do it this way. So I'm taking input of x, QS of I equal to x. Now I'm taking input of y, QS of I minus 1 equal to y. Okay, this should be fine now. Okay, now I'll output the middle value. So if this is decreasing at m, and if this is increasing at the next index, I'll do this. Okay, let's see if this works now. Okay. Oh wait, okay, sorry. I should not copy paste this. Okay, let's say we have 5 values, and let's say our array is like 1, 2. Okay, let's say 5, 4, 1, 3, 2. Right. So 2 and 1 are local minimums. Okay, it's asking what's at 3. I'm saying it's 1. 1 is at 3. It's asking what's at 2. I'm saying 4. It's asking what's at 4. I'm saying 3. And now it says that 3 is a local minimum. And that is correct, right? 3 is in fact a local minimum. Now let's take 5, 4, 3, 2, 1. Let's see what happens now. And say I have 5. It's asking what's at 3. I would say 3. What's at 2? It's 4. What's at 4? It's 2. Right. Okay, now it's not. Okay, it's not actually. Oh wait, I'm dumb. Okay, I haven't even updated the range here. Okay, I will say if query of. Okay, I'll take if query of m, right? So if query of m, and I'll say if not query of m plus 1, right? So if not query of m plus 1, I'll do this. And anyway, I need to take L equal to m in this case, right? So I need to take L equal to m in this case. And otherwise, else I'll take R equal to m. Okay, I need to do L equal to m and R equal to m, right? So I need to update the bounds. So I'll be doing that. So basically what's happening is if it is decreasing, like if it's decreasing at this point and if it's increasing at the next point, I'll immediately output this. Otherwise, I'll say if it is decreasing, then I need to keep going in the decreasing direction, right? So I need to keep going in the decreasing direction. If it is increasing, I'll keep going in the increasing direction. Like I'll go the opposite way. Like I'll keep going in the opposite direction of the increasing direction because that will be the decreasing direction, right? So I want to get to a point where both of them are 0. Like both of them are at the minimum, basically. Okay, let 5, this would be 3. At 2, we have 4. At 4, we have 2. And at 5, it's asking what's there. I'll say 1. And it says 5 is a local minimum. And that is in fact correct, right? Okay, cool. Let's try this again. Let's submit this. Okay, fine. Let's see. Okay. Okay, code process is taking too long to judge this. I don't know why. Is it TLEing? Oh, it is TL, like wrong answer or something. Wrong answer, invalid queries. Okay, let's see why. Why is it invalid queries? Okay, I need to output an exclamatory mark. I again forgot that. Okay, fine. Okay, after this though, I guess we can move on to the next problem. So let me submit this and we can go to the next problem. Okay, let's just try this one. Now, I won't be telling you the full solution for this because this is actually pretty hard. This problem is pretty challenging. So you should definitely try this problem on your own. Okay, let me just make sure this works. Okay, it is working. Okay, there you go. So in this problem, they are asking us this problem is called guessing the greatest. I'll send this in the chat. Okay. Now, basically in this problem, they are saying that, well, there is an array of n different numbers. There's an array of n different numbers. And in one query, you can ask the position of the second maximum element in a subsegment. So basically, you have n different numbers. And in one query, in each query, you can ask the position of the second maximum element in a subsegment. Okay, basically, let's say we have 1, 3, 4, 5, and 2. Right. So let's say I query for this. Now, the second maximum element is 3, right? So it will give me the position of 3 as 2. Now, if I say 4, 5, 2, then it will say the second maximum is this, which is 3, index 3, right? So basically, it tells us the position of the second maximum element in a subsegment. So that's the point of this thing, right? Now, they're saying find the position of the maximum element. So basically, given the second maximum element, you need to find the position of the maximum element in no more than 20 queries. You only have 20 queries for 10 power 5 elements, right? Now, generally in problems like this, what you can first do is take log n base 2, right? Log n base 2, which should be 10 power 5 over here. And that's 13. Now, we know for sure that 13 is, okay, actually, wait, that's actually not 13, my bad. That's actually 16. Now, 16 is less than 20, right? Clearly, 16 is less than 20. So we should be able to do this if we did it in O of log n. If we did it in O of log n, we should be able to do this. Plus or minus a few queries, right? So we can take 2 more queries than extra, basically, than necessary. Okay. Now, does anyone have any idea on how to approach this problem? Any idea? Okay, just think about this problem for a second. How can you find the maximum element given the second maximum element? This is a very, very interesting problem, by the way. So you should definitely try this problem out. So if anyone has any doubts, please do let me know. Like if you want any hints also, you can also let me know. Okay, I'll just wait for a second and then I'll give you a hint. Okay, fine. Here's one hint, right? Here's one hint. And the hint is pretty much that, well, if you have an array, right? Like let's say you have an array, then, well, if the maximum was not in the array, what would be the maximum? If the maximum was not in the subsegment, what is the maximum element now? Can someone tell me that? For example, in this array, the maximum element is 5, right? So if 5 was not in the array, let's say we had something like this, then what is the second maximum? Okay, sorry, I mean, what's the maximum? Okay, like Shukendu, Siddhartha, and Abdur said, it is the second, like the maximum is going to be the second maximum, right? So if you don't have the maximum, you have maximum in an array, you have the second maximum in an array, you have second maximum and third maximum, and so on. Now, if the maximum was not in the array, clearly the second maximum would be the maximum and the third maximum would be the second maximum, right? So the third maximum would be the second maximum. Now we can use this to our advantage. So what we can say is figure out the location of the second maximum element, right? So I'll say figure out the location of the second maximum element. So in this case, well, I'll just do a query and I'll get I'll get the answer as 4, right? So I'll get the answer as 4. Then I'll say, well, go to 4 minus 1, right? Say, take this array. So go till 4 minus 1. Then go from 4 plus 1 to this. Now, in which case, basically, like, okay, actually, I'll include this as well. I'll include 1, 3, 4, and I'll take 4, 5, 2. Now, well, in each of these cases, I will ask, well, which value is the second maximum? Now, in which case will we get a different answer? In which case will we get a different answer? Can someone tell me? So when I query for this, when I query for the whole array, I'll get a position of 3. Now, if I query for 1, 3, 4, what will be my position? What will be my answer? For the subarray where max isn't present. That's exactly right, Sujit. You are exactly right. So what's happening now is that when you take this, well, the max, you will be taking an array, you will be taking the side of the array, which does have the maximum, right? Like if you take 1, 3, 4, then you are going to get an answer of 2. If you take 4, 5, 2 on the other hand, you are still going to get an answer of 3. So if the answer stays the same for a different side, like depending on which side you get the answer, you can just figure out, well, which side the maximum is on, right? So you can figure out which side the maximum is. Now, after you figure this out, this should be cakewalk, right? So this should pretty much be cakewalk. So now that you have figured this out, you can just do a binary search. You can just do binary search. You'll take a whole array. Let's say, okay, let me repeat this, Sukendo. So let me repeat this part. So basically, first of all, I'll query for the whole array and I'll ask what is the second maximum. Well, I'll get the position as 3, right? So 3 is where the second maximum is. Now I'll say, well, from this position to the left side, what is my second maximum? Now for this, I'll get a position of 2. So for this, I'll get a position of 2. Now I'll say from this side to the other side, like to the right side, what is the second maximum? Well, I'm going to get a position of 3, right? So this is the original. This is the original. This is the left side and this is the right side. Now, since the right side is staying the same, we know for sure that the second maximum has to be present there, right? Like maximum has to be present there and the second maximum has to be present there. Because if you took the other side, then what will happen is that 4 will not be this, well, 4 will not be the second maximum, but rather the maximum now, right? Does it make sense, Sukendo? Is this clear to you now? Yeah. So basically, we are figuring out which side the maximum is on. Now, after we figure out which side the maximum is on, we can just do a binary search, right? We can say, okay, let's say we have a large array. let's say this is my second max, right? So my second max will always be at the beginning. Now I'll say that from the second maximum, take the middle index, like from this in this array, take the middle index, and now take the query from till that index. Take the query till that index. Is it still equal to the second maximum? Is it still equal to the same position? Let's say this position is X. If this is still equal to the position X, then the maximum is on the left side, right? So the maximum is on the left side. If the position is something like Y, then we know that it's on the other side. It's on the right side, right? So if the maximum is present, well, you will get the same answer. So if you get the same answer, you know that it's in this query. And now if you don't get the same answer, you know that it's on the other side, right? So this is how we can do binary search. Now I'll leave it as an exercise for you to figure out what you will do if the second maximum is the last element. So in case we go to the left side, what will be the second, like how will I do binary search? So I'll leave this as an exercise for you, right? But is the idea clear for this problem? Does this problem make sense? And does the idea make sense? Is this clear to everyone? Okay. Please let me know with the +1 in the chat. And if you have any general doubts, by the way, please do let me know, because this is basically the end of the session, by the way. So yeah. Could you please submit this problem? I tried before, got AC for easy one, but queries exceeded for hard one with the same approach. Okay. So what I'll do is actually I'll send you my I'll send you my code, but I won't share my solution here. But I'll send you my code here, Sujit, so that because I don't want to spoil this for others, right? So I'll just send this here. So yeah, you can take a look at my solution. It should be very clear. Like my solution is very, very clear. So you should be able to understand this. So it's the same approach that I discussed here. So I'll first figure out whether it's on the left side or the right side. Then I'll do a binary search on that side, basically. Okay. Does anyone have any doubts? Any general doubts? Anything like that? You can let me know. Okay, I'll just wait for a few minutes. If anyone has any ideas too, you can let me know. Like any general doubts is also fine. So go ahead. But yeah. Okay, please do fill the feedback form, by the way. I'll share it in the chat. So please do fill the feedback form. That would be very nice. But yeah, this is basically the end of the session. Like if you have any any doubts, you can stay and ask. But it's it's up to you. You are free to leave. Okay, let's just wait for 2 minutes and then we can end the class. Thank you very much, Abdur. But this problem is not hard, by the way. I promised you this problem is not hard. Like if you just think about this with the clues that I have given you, you either go to the left side or the right side. Just think about this. Then you will be able to figure it out. Okay, so this is saying any tips on how to quickly get correct approach during a contest. Sometimes I keep revolving around correct approach, but it takes time during the contest. Okay, this is a pretty big problem, by the way. You are not alone in this. First, you need to realize that you are not alone in this. Like basically every CPR, every CPR goes through this phase at some point in their life, right? Like it happens. Don't worry about this. Like everyone goes through it at all times, actually. But what I would suggest is if you're not able to get the correct approach, if you're only revolving around the current approach, then always try to take some examples, right? Always try to take some examples and try to apply those examples to that particular thing, right? So like if you have your idea, then try to take an example. Take a big example, let's say of 10 values, let's say. Try to perform your analysis on that. How to get examples on the spot. Now, that's actually also a good question. So what you can do is just say, just take anything that is slightly challenging, right? Like take any number that's slightly challenging. Let's say you have 10 values. Generally, like there are numbers. So let's say you can take 5 values, but generally you won't get a very, very like it won't always be a good test, right? Because you might get it correctly on accident. So just take 10 values, for example. Now, what you can do is just say, well, I'll just take some random values, right? So I'll just take some random values, 1, 3, 5, 4, 2, 6, 7, 9, 10, like anything like this. You can take anything like this. You can just take random values, and then you can perform your algorithm on these random values. So try to do that, right? So the next thing you can do is try to like see how how your brain solves this. So this is a very important thing. Always try to figure out, when you have a test case, how does your brain actually approach the test case? How does your brain immediately solve that test case, right? This is very important, especially for constructive problems. Especially for constructive problems, you'll see that your brain actually knows the solution before you even know the solution, right? Like if you look at a problem, you'll immediately see the pattern, but you won't be able to realize that you are actually noticing that pattern. You just know the answer, but you don't know how you know the answer. Like you just know and you won't care. But that's the bad part. So whenever you see that your brain can immediately solve some test case, always try to make your brain do it again, but this time follow the process that it does, right? And especially if you have a correct approach, if you have basically a correct approach, well, follow that approach, right? Follow that approach on this array or any array, like, or any input basically, and see what your brain is doing. How does your brain approach this? How does your brain solve this, right? And then you will be able to see that you actually do way better than before. So yes, examples always help. So examples always help. Do take examples always. But yeah, that's basically the idea. Okay, cool. Yeah. Anyone else has any doubts? Any general doubts? Yes, Vishal, that is actually true. Like sometimes it does take a lot of time to think about edge cases and all of that. Like yes, that is that is also a very big issue. I'll be honest with you. Like again, most CPS experience this at all points in their career. So yes, that is also a case. But what you can do is generally think about what the edge case would be. Like the issue is if you know it's wrong and treat as 2, but if you don't know where it is, like you don't see any test cases, then that is an issue, right? Then that's an issue, like, and it's basically unfixable, I'll be honest. But what you can do is write a random test case generator. And let's say you can also write a brute force solution, right? So what you can do is take a random test case generator, run it, and look if the answers are correct, right? Like it depends on the problem. Sometimes you might be able to brute force it quickly. Like let's say you want to convert an O of n square algorithm to O of n, but somehow you are failing, right? Somehow it's giving you wrong answer. Now what you can do is take the brute force, take the wrong answer one, and try some random test cases, right? So just write a random test case generator and do that. And this will be very easy if you do use Python. If you use Python, then you can immediately like write a random test case generator. But yeah. Okay. Okay. I'll just wait for a few minutes and then we'll be ending the class. Like if anyone has any doubts at all, you can let me know. Okay. Okay, cool. I guess that will be the end of today's class then. Thank you everyone for attending, and please do fill the feedback form, by the way. Please do fill the feedback form. That would help a lot. But yeah. Okay, cool. Okay, guys. See you again next time. Bye. And hopefully I'll take more classes later. Okay, then. Bye.